Okay, so I'm making this video to go over speed and velocity because we often don't make it through the entire set of problems. And I always want to show students how to solve all of these. So that's what we'll do. We'll go over the practice speed and velocity problems for the day, how to use the guess method, that's this, to solve those, and solutions for those things. All right, so we'll do this on paper. First thing I'm going to look at is my Google slide. All right, so that's this link here, and here's our slideshow. And this is our first problem. Jose throws the football 50 meters in 3 seconds. What's the average speed? So to solve this one, all right, here's example 1. We are given the distance is 50 meters. The time is 3 seconds. And our unknown speed, the equation for speed equals distance divided by time. Now we can substitute in what we were given. And by the way, in case you're wondering why we're doing this, all these steps, when maybe you just want to divide these things, and you're maybe just thinking, oh, I should just divide, the problems are going to get much more challenging. So if we get the procedure down when the problems are easier than when the problems get harder, we'll already have that foundation of a good procedure and good problem-solving skills. So I'm going to plug in 50 meters for distance and 3 seconds for time. And the last S is to solve. And so this is 50 over 3, which is, do this on my calculator here, I believe it's 16.66666. It is. So 16.6 repeater, and that's meters per second. And we don't get to keep this many digits for our answer. If you look up here, we only have one significant digit here and only one there. And either of those things would mean that we're only allowed to have one significant digit in our answer. What that means in simple terms is that our answer can't be more specific than what we started off with. So 16.6 is too specific. We have to cut this answer down here. All right, we're only allowed to have one significant digit. And so we're going to look at the number to the right of my cut line to decide what to do. It's a 6, so I'm going to round up, and this becomes 20 meters per second. So that is going to be my answer right there. All right, next example. All right, next example, this one. And you can pause it. Dog runs half a kilometer at 40 miles per hour to catch a squirrel. And we have to deal with a couple of things here. One, we have to figure out how long did he run, so that's a time. And then 2, we need to figure out, we have to convert something because we have miles and we have kilometers. So here we go. All right, so that was example 1. We'll do example 2 over here. So our givens. We know the distance is 0.5 kilometers, and I'm already noticing that that's one significant digit. We have a speed 40 miles per hour. I'm going to rewrite it like that. There we are. My unknown is time. My equation. So I want to rearrange the equation, which is speed equals distance over time, to get time by itself. So if I multiply both sides by time and divide both sides by speed, I end up with this rearrangement. Time equals distance over speed. And so this is the equation right here that I'm going to use to solve. All right, so now I'm going to substitute or just plug in to this. I've got 0.5 kilometers. Forgot to write the time. 0.5 kilometers divided by 40 miles per hour. Well, I can't do anything with this because the units aren't the same. So I have to fix something here. So I'm going to do a little sidebar action here. I'm going to convert miles into kilometers. So I remember from last class, we said that 1 mile is equal to 1.6 kilometers. So if I want to convert 40 miles, I'm going to put miles in the denominator, kilometers in the numerator. There's 1.6 kilometers for every 1 mile. Miles cancels out. And I end up with, I believe this is 64. Yep. 64 kilometers. That's what this is. So now I can take this and go back up there, and I can rewrite this as 0.5 kilometers divided by 64 kilometers per hour. Don't forget the per hour part. That's really important. Okay, now that I've done this, I can cancel a little bit. All right, the kilometers can now cancel, and I can divide them. And I'm going to end up with an answer that's in hours. Remember that whenever something is in the denominator of the denominator, the way you get it out of there, right, because we don't like to have fractions inside fractions. Remember from math class, the way you get this out of here is you multiply by the reciprocal. So if I want to get rid of 1 over hours in the denominator, I'd multiply the denominator by hours over 1, and then I'd do the same thing to the numerator, right? You always have to keep things balanced, top and bottom. And so I'd end up with a unit of just hours. It would look like this. Let's see, 0.5 divided by 64 is 0.0078. I'm sorry, this is kind of small, hours. So this is what I get for an answer. There's a couple of issues with this, and we'll go down past my little sidebar here to finish this up. One is there's too many significant digits. I'm only allowed to have 1. So again, I would have to cut this answer off, all right, after the 7, and I'd have to do some rounding. All right, so I've got 1 significant figure or 1 significant digit. And so that means that 0.0078 hours turns into 0.008 hours. This is just 1 significant digit. So this could be my answer. But I would say that this is a little bit odd. All right, if you wrote this answer, that's correct. But it's a little bit funny because nobody ever says that, right? When units of time are this small, or amounts of time are this small, nobody says, oh, how long is it going to take you to run down to the corner? 0.008 hours? Huh? Nobody says that, right? We would use a smaller unit of time. So if I want to do that conversion, and this is good practice, I'll actually take this before I round it. So I'll take this 0.0078 hours, and I'm going to convert it to seconds. So remember, for every 1 hour, there's 3,600 seconds. Hours are going to cancel, and I'm left with 28 seconds. Again, I only get 1 significant digit, so I have to cut this, and so it's going to end up being 30 seconds. Either of these answers right here would be okay. All right, moving on to the third example. So for this one, it says, and you can pause it if you want to, Axel rides his motorcycle at an average speed of 20 meters per second for 20 minutes. How far did he ride? So I'm trying to find the distance. I can see right now that my 2 units of time don't match. So I'm going to have to convert minutes to seconds or seconds to minutes in order to solve. So let's see how to do that. Okay, givens. We've got speed equals 20 meters per second. We've got time equals 20 minutes. Our unknown is distance. Equation is going to be distance equals speed multiplied by time. And we can substitute in, and then we're going to have to make some adjustments and then solve. So this would be distance equals 20 meters per second, and we would multiply that by 20 minutes. I can't cancel anything, even though I have seconds down here in the denominator and minutes in the numerator. I can't cancel because they aren't the same unit. So I have to convert one. I'm going to convert 20 minutes into seconds. So how do I do that? Let's see. For every 1 minute, it's 60 seconds. All right, so when I do this, the minutes cancel, and I'm going to end up with 20 times 60. That's 1,200 seconds. By the way, you don't have to round this. We're in the middle of a problem. You don't want to round ever until the end. All right. All right, so this is my little sidebar. I actually did it on the side this time. Look at me. And so then now let's solve. All right, distance is going to be, so 20 meters per second. This stays. And the 20 minutes is now going to be 1,200 seconds. All right, this looks a little bit different from our normal cancellation, right? Normally we're looking at fractions like this, but it's good to be flexible. So this seconds is in the denominator, this is in the numerator, so those cancel. And I end up with an answer that is 20 times 1,200, and so that's 24,000 meters. And it's good that it's a meter because it's supposed to be a distance, so that makes sense. The unit makes sense with what we were looking for. Unfortunately, too many significant digits, right? We started out with just one, and so we want to end up with just one as well. So, what do we get? 20,000, right? We're going to look at the 4. The 4 is going to say round down or stay, and so we got 20,000 meters. This would be the correct answer with one significant digit. All right, and that is all 3 of the examples from the speed slideshow. To follow those up, we have 4 practice problems, and we're going to solve those right now as well. So here's those. All right, 1, 2, 3, and 4. All right, so we're going to solve those. We'll start with the first one. Celeste backstrokes at an average speed of 8 meters per second. How long would it take her to complete the race of 200 meters? Here we go. All right, so this is problem 1. And so my givens, we know her speed, 8 meters per second. We know that the distance is 200 meters. Our unknown, time. Equation. All right, so we want to solve the equation for time. I feel like we did this already. Yeah, we did, right over here. All right, so we can just take that. Time is distance over speed. And yay, we can just plug in and solve. This one's pretty straightforward. There's no converting to do. So we've got 200 meters, and we're going to divide that by 8 meters per second. What cancels? Oops. Meters cancel. We've got seconds in the denominator of the denominator. And just like over here, when we had hours in the denominator of the denominator, we multiply the reciprocal and bring that up. And so our answer is going to be 200 divided by 8. What's that? 25. And it's in seconds. Now, we just get one significant digit. So, oof, how do we deal with this? Well, a lot of you will probably want to think that rounding to 30 is what makes sense. But there's actually a rounding rule, and we're going to cover this in a flippin' physics video, that says because of statistics, you actually want to round to the nearest even number, and this is only when something ends in a perfect 5, like this. So with this, I would actually, since I only get one significant digit, I would actually just round to 20 seconds. I would round down. And again, I know that feels kind of, but the reason for that is if anytime we ended in a 5, if we always round up, what we're actually doing is being statistically incorrect, right? We're always inflating the sizes of our numbers and not moving them down. And so in order to balance that out, the rule is actually to round to the nearest even number. So the options for 25, and I'll put this over here on the side, would be to either round up to 40 or down to 20. And this is, again, because it ends in a perfect 5. So, and a perfect 5 is a 5 with nothing after it. So, you'd round down to 20 or up to 40. Those are your choices. Just think of which of these is closer. 30 is not an option because it's not even, right? The 4 is even and the 2 are even, right? The nearest even numbers to this, and so we go to 20. And so that's why this is the answer. And if that's a little fuzzy, that's okay. You've probably never heard that rule before, but it does make sense, and we'll go over it via a video and a little bit of chatting later. Okay, there's my answer for that one. Let's go to problem 2. Problem 2 says, Marisol's calculations of a tarantula showed that the spider was able to cover 20 centimeters in 5 seconds. What's the average speed of the spider? Alrighty. Given. We know a distance, 20 centimeters. We know a time, 5 seconds. Unknown, speed. Equation, speed equals distance divided by time. Substitute in. Speed equals 20 centimeters divided by 5 seconds. And substituting, or solving, I should say, speed equals 4 centimeters per second. All right, there is nothing to do here. We have one significant digit in each of our inputs, and there's only one in our output, so we don't have to round anything at all. That's it. That's done. Number 3. Ashley's SUV was detected exceeding the speed limit of 60 kilometers per hour. How many kilometers per hour would she have been traveling over the limit if she had covered a distance of 10 kilometers in 5 minutes? All right, so I see that there's hours and minutes, so we're going to have to adjust something here. I think we'll go from minutes to hours since most speeds are usually in something per hour, like this. So let's convert 5 minutes into hours, and then let's solve the problem. All right, we'll do this one here. Since with that conversion, this is going to take up a little more space. So my givens, we know that her distance is 10 kilometers. We know the time, 5 minutes. Our unknown, speed, equation, is speed equals distance over time. I want to convert the time to hours. So 5 minutes, and I'm going to multiply that by 1 hour for every 60 minutes. My minutes are going to cancel. And I'm going to get 5 over 60, which is 1 over 12, I think. Yeah, so this ends up being 0.083333. All right, just the threes repeat. So that's that. So I'm going to substitute in. So speed is 10 kilometers divided by 0.083 repeater bar. And this is now going to be, oops, I forgot, hours. Okay. Solve. Speed is whatever this is. So I'm not going to round this number. I'm just going to put a 10 over it, hit divide, and I end up with 120 kilometers per hour. Now, that's how fast she was going. The question isn't, though, how fast is she going? It says how many kilometers per hour would she have been traveling over the limit. So if she's going 120 and the limit is 60, right? So she's going 120. The limit is 60. How far over is she? And the answer is that she is 60 kilometers per hour over. And we only got one significant digit there, and there's only one in our answer. All right, so we're good there. Let's do our last speed problem. Last speed problem. What is the average speed of a bus going from Los Angeles to Sacramento if it travels 385 miles in 8 hours? Okay, so my givens. I know a distance, 385 miles. I know a time, 8 hours. My unknown, what is it? Speed. Equation, speed equals distance over time. Let's plug in. 385 miles divided by 8 hours. All right. And I'll solve. This should be pretty straightforward. I don't have to do any converting. 385 divided by 8. I get 48.125 miles per hour. Okay. I only get one significant digit because of this. 8 hours right here. Darn. Okay. Well, that means I don't get to be very specific in my answer, but this is good practice. So that means I have to round my number after one significant digit. That means I have to round it after this 4. The 8 is going to tell me to do what? Go up or stay. All right, it's going to tell me to go up, so that means I go up to what? To 50. It's going to be 50 miles per hour. And that, my friends, is the answer. So there you go. There's the whole shebang. This is for all of the speed examples and speed problems. Hopefully that helped.